questions from set 2, and this is going to ultimately end with the unit of moles. Either moles of an individual atom or moles of molecules. So the example could be an atom of oxygen. Molecule, your example is H2O. So remember, atom is one element. Molecules is two or more elements. So looking at this question, let's focus on example C. C is starting with molecules of H2O, and we want to end up with moles of H2O, so moles of this molecule. And so if I go to my general relationship of moles to atoms to molecules to particles to grams that I've written up at the top in blue, if I look here at what units I have and what units I'm trying to get to, I know that I'm starting with molecules, so I'm right here right now, which means that I have this value with it, and I'm trying to get to moles. So I'm going to set this up so that I start with my data, which is 3.011 times 10 to the 23rd molecules of H2O. I want to get out of molecules of H2O and into moles of H2O, so I'm going to put down 6.022 times 10 to the 23rd molecules of H2O in my denominator and 1 mole of H2O in my numerator. And now if I go and look at my units, molecules of H2O cancel out, and I'm left with moles of H2O. For the rest of it, for the calculation part, just plug it into your calculator using your shortcut. So you're going to be dividing these two, right? Because you have a 1 in the numerator and an actual value in your denominator. So let's take another option. Let's look at F. F is extremely similar to C. And so with F, we're starting with molecules of C4H10, and I still want to end up with moles of C4H10. How do I know that? Well, that's what all of question 2 is asking me, to end with moles. So I'm going to start with my data, which is 8.25 times 10 to the 13. I'm going to use MOLEC as my shorthand for molecules. And I want to get out of molecules and into moles. So my only option with molecules is Avogadro's number, 6.022 times 10 to the 23rd. And that always equals 1 mole. So now I just need to write this up as my conversion factor. So I have 6.022 times 10 to the 23rd molecules of C4H10. That's my denominator. My numerator is 1 mole of C4H10. Again, when my units cancel, molecules cancel as molecules, I'm left with moles. So let's take a look at E. E is a little bit different because E is starting with grams, and we're no longer dealing with an individual element, we're dealing with an entire compound, a molecule here. So this is where it's going to be really important for me to have my molar mass. How did I immediately know I needed molar mass? Well, remember, molar mass is your relationship between 1 mole to the grams of the atomic masses from the periodic table. So molar mass always helps you go from grams to moles or from moles to grams. So if I just combine this, I can just say it's always grams to moles or moles to grams. So I just write it out this way, representing that relationship. So if I have the unit grams and I'm trying to end with moles, I use molar mass. If I have the unit moles and I'm trying to end with grams, I use molar mass. And this requires me to go to my periodic table and do some calculations on my own. And so if I were to add up my molar mass for copper nitrate, This is going to be copper 1 nitrate. I believe nitrate's NO3 with a -1 charge. So this should be copper 1 nitrate. If nitrate's a 2- charge, then that means it's copper 2 nitrate, but I'm pretty sure nitrate's a 1- charge. So this is my compound. What I'm going to do to get my molar mass is I'm going to go to my periodic table, find my copper, find my nitrogen, find my oxygen, but I have 3 atoms of oxygen, so I want to account for everyone involved. I believe nitrogen is 14.077, but I'm not too sure. Let me double check. So nitrogen is 14.007. Oxygen, of course, is 15.999. And copper is 63.546. So if I were to add these all up, I would now have my number and then grams per mole. So that means that many grams per every 1 mole. So what I want to do is I want to eventually end up with moles. So that means I'm going to start with my data, which is 125 grams CuNO3. I want to get out of that. I want to get out of grams into moles. I just need to put down my grams of CuNO3, and that's always equal to 1 mole of CuNO3. So this number right here, I'm going to let you calculate that on your own. What you're going to do is you're going to multiply 3 times 15.99. You're going to add it to 14.077. And then you're going to add that to 63.546. You should get an answer that's very close to 126. So I'm going to go ahead and just put in here 126. It'll be 125 point something or something close to that, right? 125 point something. So I'm just putting 126 in quotation marks. So that number right here would then go in your denominator. And it's probably 125 point something. So grams of this cancels the grams of that, and I'm left with just moles.